Hi, my name is Juan Manfredi, and I'm the team lead for the Data Gaps team for the California Safe Water Data Challenge. So I'm going to show you the problem that me and my team have been working on for the past few weeks. The name of our project is Better Data Quality for Better Water Equity. So you can see here our GitHub repository where we have all of our code as well as documentation about how to actually use it and describes it a little bit more in detail. But I'll show you sort of from a bird's eye view what our code does. So first, starting with our team, like I said, my name is Juan. I recently moved to Berkeley to be a postdoc in the Department of Nuclear Engineering. And I moved here from Michigan State University. And while I was living in Michigan, I spent time volunteering in Flint, Michigan in the wake of the water crisis there. And that's when I really started to care about access to safe drinking water. And then when I saw that there was a hackathon going on, hosted at the Berkeley Institute for Data Science, gave me the perfect opportunity to combine my technical background, like I said, in the nuclear physics, nuclear science world, a lot of programming, with an issue that I really cared a lot about in safe drinking water. And there at the hackathon, I met Spencer Harris. Spencer is a hydrogeologist at Lawrence Livermore National Lab, and he's thought a lot about water issues in his academic past. And then he connected us with 3 students from the University of Pennsylvania master's program that Spencer graduated from, who also think a lot about issues like access to safe drinking water. And so that's our team, the Data Gaps team. So at the hackathon, Spencer and I were trying to decide which problem to work on. And Rafael Maestu, who's I think he's the chief data science at the California State Water Resources Board. We were trying to talk to him about what projects would be actually impactful and actually make a difference from the perspective of the state government employees and the stakeholders who actually work with California water data on a daily basis. And what Rafael talked to us about was a particular data set. In the challenge data sets, it's called data set number 8. And I can bring up data set number 8 here for you now. Just make it a little bigger, sorry. But while that's loading, I can explain to you that this basically every year, every single public water system in the state of California submits a survey, and I can show you what that survey looks like, about water usage for that year. So you can see here, there's lots of information that they provide, demographic information about the public water system, and then also things like water sources. So how much water are they getting from groundwater, from surface water? How much are they purchasing from other districts or selling to other public water systems? What types of destinations are they sending the water from, or the water to? So residential areas, agricultural, industrial, commercial, etc. And also for each month of the year, how much water are they producing, from where, how much of that water is potable, etc. So you can see here that this survey is 18 pages long. So it's just tons of information for every of the almost 7,000 water systems in the state of California. So one would think that this would be a really rich source of data that a lot of insight could be extracted from. And Rafael was talking to us about this data, and he told us that it's a shame that the state spends a lot of time and effort actually gathering and collecting this data over the past several years, but that due to a few issues, a few critical issues, there actually hasn't been that much use, that much analysis of this data. So now that the actual data set is loaded, I can show you what it looks like. So basically, this spreadsheet consists of several different sheets that have data for many different water systems. So for instance, here you have the names of water systems, what their classification is, and then also information about, if you start scrolling to the right here, you see just how many rows or how many columns there are, data about their population, about what type of communities they serve, about how much water they produce from different sources. And then you quickly sort of start to get overwhelmed by this data. I mean, we're talking about thousands of rows and thousands more columns. And you see here, for instance, in this second sheet, they have all this information for each individual month. So here we've got the water produced from groundwater for the month of March for all the different water systems, and then surface water from the month of March. And then over here, the same thing for the month of April. And so if you're familiar with using Excel, you might realize that it's actually quite difficult if you, for instance, want to look for a given water system, how their water usage changes over the course of the year. You're going to have to go through and pick out individual cells from this Excel spreadsheet and put them into a different Excel spreadsheet before you can do any actual analysis. And Raphael told us that this was a major problem. You know, maybe someone with his data science background and his experience can eventually finagle it, but someone who doesn't have that level of expertise isn't going to be able to get anything out of this data. And so what we decided to do as a team, oh, sorry, one other problem that I should have mentioned is that the actual quality of this data is not very well cleaned before it's put into this data set. So there's, for instance, misspellings, incorrect answers for particular parts of the survey, missing answers. So there's also a data quality issue, a data cleaning issue, so to speak. So our team wanted to address both of these problems. And so first I'll talk about the data transformation aspect. So in other words, we have this data set, we know it's full of good information, but it's very hard for us to actually tease that information out. So the data is full of answers, but it's very hard for us to ask the questions because the data set is so clunky and unwieldy. So what we did was we wrote a couple of data transformation scripts, and these scripts basically take this data and transform it into a more usable format. So I'm going to show you on the GitHub repository an example of what one of those scripts looks like. Oh no, actually what I'll do, sorry, I've got the GitHub repository cloned here to my local machine. So this wasn't the machine that I wrote all this code in, just to show you that I've just pulled the GitHub repository down and just how quickly this gets working. In the README, I describe in detail all the different packages you need. Really, there's nothing super advanced. This is all written with Jupyter Notebooks, which is a really common way to write and execute Python code. If you download the Anaconda distribution, which is basically a Python package manager and environment manager, the link to which is in the README, you'll be able to do all of this without a problem. So what I'm going to do is I'm going to start a Jupyter Notebook server. And that should open right here. So now we've got this Jupyter Notebook server with all the different codes here. So the repo basically has an input data folder where, for instance, the raw electronic annual report data is that I just showed you. It's got a couple of EAR to water Python notebooks. So here we have two different Python notebooks corresponding to two different final formats. So I'm going to show you one of them in particular for the EAR to water produced final format. And so talking to Raphael, because I'm not an expert on water usage, for instance, talking to Raphael, he gave us two examples of final formats that he has made in the past by hand that were useful for analysis. And so basically what the goal of our Python notebook is to take in this raw data, you see it's being read in here, parse and pre-process that data, and then eventually output data into a final format. So you can see here, I'm actually going to run this data so you can see that it all runs in a reasonable amount of time. And while it's running, I'll sort of show you how it works. So we're using the Pandas Python data science library. It's a very commonly used, very well-maintained library for doing data science in Python. So you can see that just in a few lines, here you can see PD representing the Pandas library. We can read in this Excel file. We can parse individual sheets in the Excel file, and then we can concatenate them into a structure called a data frame, which is basically a structure very convenient for manipulating and transforming raw data. So then after we've read this data in, we go down here to the main analysis loop, which is down here. Basically what I'm doing here is looking through this giant data frame, pulling out the columns of interest, and then rearranging them and calculating new quantities based on them in order to actually make this new data format. So for instance, we have the water produced per month from groundwater, from surface water, water that's purchased or sold to other public water systems, how much of that water is recycled. We have the population of the public water system that we read in, and then even the number of days in that particular month we read in, so we can calculate quantities, like for instance, the the total potable water produced in gallons per capita day. So that way we can tell in a way how much water is being produced, normalized to the how many days are in that particular month, and to how many people are in that particular water system. So then at the end of this analysis loop, we write out, oh, it just finished. We write out this big data frame to an Excel file. So now I'm going to show you what that final Excel file looks like. It's just written right here to our output data, water produced. While Excel is opening that, here we go. So now you can see that we've got the same data now rearranged into a much more convenient format. So you see here we've got the water system name, we've got the month. For each individual month, we know how much total water is produced from all sources, and we can do something like, for instance, very quickly make a nice scatter plot. Sorry. Insert. So now we can see for the different months of the year exactly how the water use changed. And so if I'm trying to analyze this data, I would think, oh, during the summer, we're getting an increase in water usage. That's interesting. But then here at the end of the year in December, all of a sudden the water use spikes. So now me, as an analyst, I might think, okay, this is maybe worth investigating. Maybe there's a problem with the data. Maybe there was some event in this water district that required a big boost in water. Now we can narrow down and focus further on this particular water district this particular month. So that was basically our goal. Our goal was to take this raw, unwieldy data and make it much easier for stakeholders like state and government employees or citizens of the state of California to analyze it and learn from it. So it's not the sexiest project, but it is a practical project. It is a feasible project, and it's very easy to implement. Basically, I've implemented right now in front of you, and it would be easy for anyone else to do the same thing. Now, there's one other script I'd like to show you, and that's this data inspection script. This is a more preliminary project that we worked on basically trying to understand where are the problems with the data. What sorts of issue are there in terms of the data quality, or what I call the data hygiene? So basically, it's also using the Pandas library, but now it's using a lot of different functions to analyze the data in a lot of different ways. So there's a list of them down here. This takes a long time to run, so I'm not going to run it here for you. But basically what it's doing is it's looping through that big raw data set, and it's tagging individual water systems for different problems. So for instance, when do you have non-alphanumeric characters in a column that's supposed to be alphanumeric? When do you have misspelled rows? When do you have leading spaces in your columns or in your rows? What's the variance of a particular column? So how much are the values changing? What's the mean? How often do you have strings in a column that's supposed to have numbers? So this was worked on by the team from UPenn, and they did a really nice job of basically asking lots of different questions of, okay, how often are these different errors happening, and what errors are happening? And so this is an area that now we would like to work on more of, okay, now that we've actually started to diagnose some of these problems, how can we actually fix those problems or give advice for the people gathering the data on how to catch those problems in advance? So that I'll end with another note on the future growth of this project. So I just talked about the data inspection aspect. For the data transformation aspect, those two scripts that we wrote were for two particular output formats. It would be very easy to adjust those scripts to make any other number of output formats. And so that's one thing that we were particularly excited about. If there's a certain type of question that someone has, you could write an output format script for that particular question. So for instance, I showed you the water production script when we're interested in, okay, how much water is being produced. The other script we wrote is about water delivery. So how much water is being delivered, and where is it going? To commercial, to industrial, to agricultural purposes, etc. And we really think that there's a lot of possibility there for different output formats for different analysis questions. So that sums up our project, Better Data Quality for Better Water Equity. We really hope that you've enjoyed it. Please reach out to us if you have any questions. And yeah, we hope that this can be useful for the state of California in studying water usage. Thank you.
Awesome.